All right, everybody. Here's a week 31 block day 1 study guide. Now, reviewing it, I noticed, oh man, there's not enough space. So we'll try to do what we can do, okay? So I'm going to make this a little bit smaller. So we've already done this previously. So I'm going to go over here and I'm going to multiply the 2 to the 3x. I'm going to use the distributive property. So distributive property. So 2 times 3x is 6x. 2 times minus 5 is minus 10 is equal to 2x plus 6. Then I'm going to use the subtraction property of equality to move the variables. So there's the subtraction property of equality. Notice that the distributive property did not have of equality. Because when we do the subtraction property of equality, we're going to do it on both sides. The distributive property is just with that parentheses. Now I'm going to use the addition property of equality right now to add 10. So the addition property of equality. After that, I get 4x is equal to 16. And now I just need to divide by 4 on both sides to get x equals 4. And if I divide by 4 on both sides, that's going to be the property of equality. Okay, next up, A. So I notice that the x's are on both sides, so I'm going to move it so that they're only on one side. So I'm going to do the opposite reaction of minus 2. The opposite reaction of minus 2x is, all right, so I get 32x. This was so what property of equality was that? All right, that was the addition property of equality. Next up, I'm going to divide by 32 on both sides using the division property of equality. And then I should get x is equal to 1/2. That's just simplification. So yeah, I'm going to tell you right now, that's not enough space. Now this would be a great show your work on a separate paper and then write your answer here type of deal. But I'm not a big fan of that because I want to see your work. So yeah, that's my opinion. Now this is determine whether each equation has one solution, no solution, or infinitely many solutions. So one solution is where like x is equal to a number, like 4, 5, 6, just one of them. No solution is where like when you isolate it, you get like 4 is equal to 3 because that doesn't work. Infinite solution is where you get it all the way down, you simplify it, and you get like 3 equals 3 or x equals x. And you're like, when does 3 equal 3? Is this always true or never true? Well, it's always true. So it's infinite solutions. Now, that's a wrong answer. It should be all real numbers is the answer, but that's more of a next year type of deal. So if I solve these, I don't need to show my work now. So, well, I don't need to justify, but it's always nice to. So I'm going to say what I do. I'm going to divide. I notice that the 2 is a factor for every other number. So I'm going to divide by 2. I get x minus 1 plus 6. Oh, nope. 6 divided by 2 is not 6. It is 3. Is equal to 4. Nope. Go back. 4x divided by 2 is 2x minus 11. Now, if I minus x on both sides, I'll get, and if I combine this, I'll get 2 is equal to minus x, x minus 11. If I add 11 on both sides, I'm going to get 13 is equal to x. Now, that's not the answer. The answer they want is one solution, no solution, or infinite many solutions. Okay, so A is going to be one solution. Next up, I see this right here. I'm going to, once again, I see that 2 is a factor in all of these, so I'm going to divide by 2 all the way across. I get 3 times 2x plus 1 minus 1 is equal to 6x plus 2. All right, if I multiply this out, I get 6x using the distributive property. I get 6x plus 3 minus 1 is equal to 6x plus 2. If I cancel these out, 3 minus 1, I get 6x plus 2 is equal to 6x plus 2. I'm going to tell you right now, that's the same equation on the left, expression on the left and the right side. So that if I boil this down, I'm going to get, like if I subtract 6x on both sides, I'm going to get 2 equals 2. So 2 equals 2. When is that true? Always. So the solution set is all real numbers. Next up, it says solve the formula. Number 3. It says solve the formula C is equal to 2 pi r. Okay, let's divide the r. To get rid of r, we have 2 pi with him. We're going to divide by 2 pi on both sides. I get C over 2 pi is equal to r. Is r by himself? Yes. Then we are done. Now, if there was like a plus d or something, we'd subtract by d first, then divide by 2 pi. You have to make sure you work your way from the outside, farther away from r, well, or whatever variable you're solving for, until you get to the very variable that we're trying to solve for, which was r. All right, number 4. Remember that standard form is ax plus by is equal to c. So we're going to multiply both sides by 4 because we don't want fractions in standard form. So if I multiply by 4, I'm going to get 4y is equal to negative x plus 12. Well, the x has to be on the other side, so I'm going to add x on both sides. So I get x plus 4y is equal to 12. Now, technically, is 1x plus 4y. Let's see. ax plus by equals c. ax plus by equals c. Done. No fractions. We're good. Solid. Write the equation bunk, in general form. All right. Well, basically, just solve for y. I like slope-intercept form myself. I don't like it when it says general form. It's like slope-intercept form, but whatever. So I'm going to isolate for the y. Y equals m times x plus b. Okay, well, let's do it. So we're going to use the subtraction property of, to solve it. So I get 3y is equal to negative 2x plus 9. Divide by 3. Divide by 3 using the division property of. All right, when I divide by 3, I get y is equal to negative 2/3 x, and 9 divided by 3 is. All right, let's go on. Now, we've gone to our current unit that we are learning, the inequalities. So it says solve the inequality and graph the solution on a number line. All right, I look at this negative 4. I know that I could divide both sides by negative 4. But let's use the distributive property. So if I use the distributive property, I'm going to multiply negative 4 to the x and negative 4 to the 1. I'm going to add 4 on both sides. Now you're going to see right now, you're going to see that we're going to divide by negative 4 anyways. We should have done that, but it's always a nice bet just to distribute out, get rid of that distributive, that grouping, that parentheses, using the distributive property. All right, if we multiply by a negative number, like if on the denominator there is a negative, like negative 4 right here, what do we have to do to that inequality sign? We have to. Okay, let's go on. So we'll get x is less than or equal to negative 4 instead of more than or equal to. So all you have to do is you put a negative 4 right here. Let's make this like negative 6. Let's put this negative 2 right here. 1, 2, blink. 1, 2, blink. Is it an open or closed? It has an equal sign, so it is. All right, fill it in. And now, which direction is it? Well, it says the number is smaller than negative 4. Okay, well then smaller number is going left. Done. Now it says graph each compound inequality on a number line. Okay, so if it's and, it's where they overlap. So I'll go like this. 4, and I'll put negative 1. So I know x is smaller than 4, so it's going this way. I know x is bigger than or equal to -1, and it's going this way. So if it's an and, I don't care about it continuing, because technically, then it's going to continue this way. And technically, this is going to go this way, but we need where are both. So the answer is going to be this shaded region right here. -1, x is bigger and equal to -1, but less than, not 0, less than 4. That's in compact form right there. All right. Now we have x is less than or equal to -2. And so what we can do, let's make this -2. Let's make this 3. Why? Because we just have two numbers. We place them on the number line. We don't need to scale it until we get to the quadrant plane where we have to really scale, because it's very important for slopes and stuff. All right. It says x is smaller than or equal to -2. So it's going to go this way. And it says x is bigger than 3. So open circle going this way. All right, guys. There you have it. There's the problem. I mean, if we wanted to write down what is the solution set, it doesn't change. For this one, it's this. If they overlapped, then it'd be all real numbers. All right, guys. I hope you have a wonderful day. We're going to do block day 2 in just a little bit. Have a good one, guys.